Hi everyone. So today we're going to start with the material for test 4. And so test 4 has 5 sections on it: 7.1, 7.3, 7.4, 7.5, and 8.1. So this video is going to be about 7.1, and then I'll make videos for all of the rest of the sections. So if you haven't already, go to Blackboard. The links to the notes should be there. You can print out the notes and follow along with me. So I'll share my screen so you can see it, and then we'll get started. Okay. So we'll be doing something a little bit different that we haven't done before, and that'll be exponential functions. So far, all of our functions have been mostly polynomials and rational functions, which rational functions are built out of polynomials. They're fractions with polynomials in them. But the polynomial form has things that are like x to the n, or x to the fourth, x to the third, or something that's built out of that, where all the exponents are constant numbers. So your exponents are going to be things like 4, 3, 2, 1, and they're not going to be a variable. But in this section, we're going to start working with exponential functions where the variable is in the exponent. So a variable like x. Okay, so the functions that we had before were x to the n. In this case, our functions are going to look something like this, where there's a number in the bottom and an x, or a variable, in the exponent part. And these functions only really make sense when your base a is not equal, or is greater than 0. And a is not equal to 1. So all of these functions that we're going to be working with and equations that we're going to be working with, they're not going to have 0 or 1 here as your base. Okay. So eventually we'll work up to solving problems like this, like 3 to the x equals 4, but we don't really have all the tools for that yet. But what we can work would be 3 to the x equals 9. So you may be thinking, what's the difference between those two things? They look a lot alike. Well, the reason that 3 to the x equals 9 is different than 3 to the x equals 4 is because 9 is a power of 3. 9 is equal to 3 squared. So it's like there's a relationship between this side of the equation and this one. And it's the fact that they have the same base, which is 3. They're both powers of 3. And so what we are going to use to solve the questions in this section is called the exponential property of equality. So the exponential property of equality says this: if a to the x equals a to the y, so notice in that case we had the same base on both sides, which is a, then we can just set the exponents equal to each other. X equals y. And that is what we're going to be using to solve the equations in this section. So if we do the example from above, 3 to the x equals 9. Well, we need the same base. So if you look over here, we have a and a in the bottom. We need to have the same base. Well, we know 9 is 3 squared, so we can write it as 3 to the x equals 3 squared instead of 9. So now we have the same base, like our a would be 3. And so in that case, we set the exponents, x and 2, equal to each other. So we'll have x equals 2 as the answer. And so that's how we'll be working all the equations in this section. So the steps that we're using, the first thing we want to do with these is we're going to isolate the exponential term. And that means that we're going to basically get it alone on one side of the equation and then everything else to the other. So it should be like a to the x equals like a number or just equals something. After we do that, we'll write both terms to the same base. So they should be both like a to the power of something. So it should be like a to power equals a to some other power. And then we would set the powers equal to each other or set the exponents equal to each other. And that is where we take that exponential property of equality into account, is in step 3. And that part will give us our answer. Okay. So we will just start with example 1. So the first thing we need to do is step 1, which is isolate the exponential. So we need this 8 to the x by itself. So we'll do that by adding 32 to both sides. And we'll get 8 to the x equals 32. So at this point, we need to ask ourselves, what base do we need? So the first instinct may be to try and write it as a base of 8, because here we have 8 to the x. But 32 is not a power of 8. 8 to the first power is just 8, and then 8 to the second power is 64, which is already too big. So we'll have to change both sides of the equations to be the same power. So what we're going to do is we're going to think of 8, and we're going to factor 8 and see if we can write 8 as something else to a power. So 8 is equal to 2 times 2 times 2, which is 2 cubed, or 2 to the power of 3. And so now that we have that, it would be great if we could write 32 as 2 to a power also. So we'll try to write 32 as 2 to a power. So I'm going to factor 32. If we divide by 2, we get 2 and 16. And then we can divide 16 by 2. We get 2 and 8. And then 8 is 2 times 2 times 2. And so in the end, we'll have 1, 2, 3, 4, 5 2's there. So 32 is 2 to the 5th power. Okay. So now we're going to take 8 and write it as 2 to the 3rd. And then we'll take 32 and write it as 2 to the 5th. So in the end, we have 2 to the 3rd to the x equals 2 to the 5th. So now we want this side to just be written as 2 to 1 power, not 2 to a power raised to another power. But when we have 2 powers, like a power raised to another power, that means we can multiply those. So 2 to the 3rd to the x power can become 2 to the 3x. So just as another example of what's going on there, if we had 2 to the 4th to the 3rd, we could multiply that 4 and 3 together and get it as 2 to the 12th power if we wanted. So what we're doing here is we're just multiplying the 3 and the x together, and that makes this new power 3x. Okay. So now that we have it as 2 to some power and have that equal as 2 to another power, so 2 to the 3x equals 2 to the 5th, we can set the powers equal to each other. 3x equals 5. And then the last step, we will want to just solve for x, which is an easy fix right here. We just divide by 3. So x equals 5/3 is the answer. Okay. So that's the answer to the first question. Okay, 1 second, I need to grab something and then I'll work example 2. Need to make sure my laptop doesn't die. All right, so now we will go on to example 2. So we had 9 to the negative x equals 3. So we already have the exponential term, 9 to the negative x, on one side. So we don't need to do step 1, it's already done for us. So now we need to write it as both sides to the same base. So we'll think about what number we have here and what number we have here, and see if we can write them to the same power. So we know that 9 is 3 times 3, or 3 squared, and 3 is 3 to the first power. So it would make sense if we have our base equal to 3. Since 9 is equal to 3 squared, 3 is equal to 3 to the first power. So we will rewrite this, instead of 9 to the negative x, we're writing it as 3 squared to the negative x. Let's write that just a little bit bigger. Equals 3. Okay? And that's 3 to the first power if you want to write that one there. So now we want just one exponent instead of 2. And so since we have an exponent raised to another exponent, we can multiply them. And 2 times negative x is negative 2x. So this is 3 to the negative 2x equals 3 to the first. So now we use that exponential property where we set the powers equal to each other. Since we have the same base and each one is raised to a power, we can write it as negative 2x equals 1. So just as a note, you always have to have the same base. So if you have 4 to the third equals 5 to the x, that does not mean 3 equals x. That's not true. Don't do that. It has to be the same base, same thing in the bottom. So now that we have our powers set equal to each other, it's just a regular equation that we can solve. We can divide by negative 2. We get x equals negative 1/2 as our answer. Okay. So now we're done with example 2, and we can go on to the third example. So the third example is a little bit more complicated, but we're going to do the same thing. So we already have an exponential term by itself. So this 3 to the x squared plus 5x is by itself. We don't have anything else added to it. And so let's try to write both sides to the same base. So here on our left side, we have 3 to a power. Here on the right side, we have 27 to a power. So we have 27 is equal to 3 times 9, which is equal to 3 times 3 times 3. So 27 can be written as 3 to the third power. And 3 can obviously be written as just 3, which is 3 to the first power. So it makes sense if our base is 3. So our base is going to be 3. Okay, so this first side already has 3 as our base. We'll just copy it down. And then this side over here, we can write 27 as 3 to the third. And then that negative 2 is on the outside. And so with our next step, we will multiply these powers together and get 3 to the negative 6 power. So we have 3 to the x squared plus 5x equals 3 to the negative 6. And then we can set the powers equal to each other using that exponential property. So this side and this side. Okay, so now we have x squared plus 5x equals -6. This is a quadratic, so what we'll have to do is we'll have to get it to one side and then either use the quadratic formula or factor. This one factors nicely, so I'm going to factor it. So I'm going to add 6 and get x squared plus 5x plus 6 equals 0. I'll move up here and I will factor that. Okay, so for our first terms here, we split apart x squared into x and x. Then we want to split apart 6 into its factors. So the factors of 6 are either 6 and 1 or 3 and 2. But we want to make a positive 5x in the middle. So 3 plus 2 gives us 5x, so that's the one I'm going to use. So 3 and 2, and then if we want a positive 6 and a positive 5x, we're going to have to make them both positive. Okay, so now we'll set each term equal to 0, x plus 3 equals 0, x plus 2 equals 0, subtract 3 and get x equals -3. Subtract 2 and get x equals -2. So in that case, we will have 2 solutions. Okay. So we'll move on to number 4. Okay. So number 4 looks just a little bit different, but we can solve it too. What we just need to do is think about what our base should be. So here we have 8 to a power, and on this side we have 1/64. So we know that 64 is 8 times 8, which is 8 squared. And so we can write 64 as 8 squared, so our base can be 8 in this situation. So our base is 8. Okay, so we're writing this one as 8 to the 5x minus 4, so just copy down that side. And then since we have 1/64, this is going to be 1/8 squared. Okay, so we don't want 1/8 to a power, we want just 8 to a power. So what we're going to do is, instead of writing 8 squared in the bottom of the fraction, we're going to write it in the top, but we're going to write it as a negative exponent, 8 to the -2. And then this side stays the same. So if you remember, x to the -1 equals 1/x, x to the -2 equals 1/x squared. So that's what we're doing in this step here whenever we move 8 squared to the top. You can move it to the top and make the exponent negative if that's what you need to do. So now we're going to set the powers equal to each other since we have it to the same base. We have 5x minus 4 equals -2. We'll solve for x. So add 4. We get 5x equals 2. And then we can divide by 5. And then we should have x equals 2/5 as our answer. Okay. So time for example 5. So we have 1,000 to the -x equals 10 to the 2x minus 13. So let's find what base we want. Okay. So 1,000 is 10 times 10 times 10. Or we can think of it as 1,000 is 10 times 100, which is 10 times 10 times 10. which is equal to 10 to the third power. So this side can be written as 10 to a power, and then this side is already written as 10 to a power, so our base is 10. So 10 to the third to the negative x equals 10 to the 2x minus 13. All we had to do was replace 1,000 with 10 to the third because they're equal. Oh, yeah. And then we can multiply this 3 and this negative x, so it's just 10 to a regular power instead of raised twice to a power. So 10, and then 3 times negative x is negative 3x equals 10 to the 2x minus 13. So now we set our powers equal to each other. So negative 3x equals 2x minus 13. And we'll solve for x. So let's subtract that 2x and get our terms with x's together. So negative 5x equals negative 13. Then we'll divide by negative 5. So it should be 13 over 5, and then negative divided by negative becomes a positive. So it's a positive 13 over 5. And that is the answer to number 5. So one more problem in this section, and then we'll be done. Okay. So in this problem, we have 9 to the x minus 4 equals 27 to the negative x plus 4. And so let's find out what our base should be. Okay. So the first thought might be 9, but 9 to the first power is 9, and then 9 to the second power is 81, which are already too big to get that 27. So we can't write 27 as 9 to a power. But we know that 9 is 3 times 3, which is 3 squared, and 27 is 3 times 3 times 3, which is 3 to the third. And so both of them can be written as 3 to a power, so our base can be 3. So I'm going to replace 9 here with 3 squared, and then I'm going to replace 27 here with 3 to the third. So 3 squared to the, excuse me, to the x minus 4 equals 3 to the third to the negative x plus 4. So now let's multiply these powers. So we end up just getting 1 power on each side. So it should be 3 to the 2 times x minus 4. So put that x minus 4 in parentheses because we want to do 2 times all of this. We don't want to just accidentally do 2 times x and not distribute it to this negative 4. And then that equals 3 to the 3 times negative x plus 4. And we're going to put this in parentheses too for the same reason, because we're going to have to distribute those. So now let's set the powers equal to each other. 2 times x minus 4 equals 3 times negative x plus 4. And then we can distribute. So distribute that 2 and distribute this 3. Okay, so our left side becomes 2x minus 8, and our right side becomes negative 3x plus 12. Okay, so let's solve for x. We will add 3x to both sides. Get our terms with x's together, and we get 5x minus 8 equals 12. We'll get the constant terms on the other side by adding 8. We get 5x equals 20. And now we'll get x by itself by dividing by 5. And x equals 4 should be the final answer there. Okay. So I believe that that is the last example of this section. I think that one went by pretty quickly. If there are any questions about it, then feel free to email me or whoever your teacher happens to be, or tune into the Zoom sessions for the extra help. Come with questions, and hopefully everybody's safe and doing well, and this is as best as we can do in this situation. So I'll see you in the next video. Bye.